to get started now. We have people in the Zoom number, and we have quite a few people here in the first boardroom, and then we're starting to put people in the second boardroom. If anybody comes up, we have, it looks like 3 more chairs in the first boardroom. So we're welcoming people to the Science and Engineering Council. Our monthly luncheons are held the second Wednesday of each month at noon, both in person and on Zoom. Our speakers focus on topics of current interest from a science and technology angle and include extended time for Q&A. Our outreach programs include STEM scholarships administered through the Scholarship Foundation of Santa Barbara and support for the Santa Barbara County Science Fair. Our next meeting will be August 9th with Brian Milburn, who's the CEO and founder of Solid Oak Software. He'll be speaking to us also on artificial intelligence. His likely topic is how can it be used to deceive and or defend us, but he's reserving the option to adjust the topic based on current events at that point because things are changing so fast in the field. As always, feel free to contact me about particular topics or speakers you would like to suggest. If you're interested in our past meetings, we have a YouTube channel with recorded meetings from the past year or so. And subtitles are available on Zoom during today's talk if you enable live transcript in your Zoom window. You can type questions into the Zoom chat during the talk or ask them after the talk. Our speaker today is Ivan Bercovich, who is a partner at ScOp Venture Capital.
That's okay.
He is a veteran tech leader with expertise in structured data, conversational systems, and transforming complex data into valuable products and experiences. His journey began at Graphene, where he spent a decade developing the natural language understanding and generation technology that is integral to Alexa's capabilities. After Graphene's acquisition by Amazon, Bercovich continued to lead a team of 130 professionals overseeing software development, product management, and knowledge engineering. He gave a very interesting talk to our group in late 2019 on the core engineering and scientific challenges of Alexa development. His current role as partner at ScOp Venture Capital sees him as a hands-on investor. He has been involved on the boards of 5 companies while advising several others. He will be talking to us today about artificial intelligence, thoughts on AI as a practitioner turned investor. Welcome, Ivan. Thank you.
So what I did for this presentation is the first time that I'm doing it. I've just collated a lot of information that I've been consuming myself over the last few months. So it's free information then. I can speed through it in 20 minutes, but I think that would be too much. So please interrupt me if it's fun. Too fast. So just for a quick background, I come from an engineering background. Looks like I imagine lots of you are. I spent a lot of money on a cloud infrastructure, about 25 million when I was at Amazon. I was part of opening the Amazon office in Santa Barbara. I work on Alexa, which was a free large language model, but basically the same sort of objective, which is through natural language, be able to communicate with users and give them answers also in natural language. So I did a lot of work in NLP and big data, and now I'm investing of a $54 million venture capital fund. We're actually towards the tail end of the investment at this point. Just as an interesting fact, we have a company in our portfolio called Hey Tutor, which I'm currently operating. The CEO left, and we teach over 10,000 kids. We help kids in public schools, primarily in LA, but across California every week. Cool. Right. So AI, I think people have various ideas of what it means, but it's pretty straightforward. They're very simple algorithms, the simplest algorithm you can possibly imagine at the base level. Very large scale, lots of data, and that enables these algorithms to find patterns. Those patterns are converted into weights. Those weights are put in a large matrix, and then you can make predictions about new data. That's it. Some useful concepts for this presentation. Parameters is typically how we refer to the complexity of a model. So a parameter is pretty close to a weight in a matrix. More parameters, bigger matrix. Modality is what the particular model is working off. It could be text, it could be images, it could be sound. And AI is just making computers do things. Before machine learning, AI was just writing code explicitly, hard-coded to make a machine do something. That was AI many years ago. Today, AI is more machine learning, so people are not really writing the code explicitly, but giving a lot of data to a machine, and the machine learns patterns. A neural net is just a way to do machine learning, right? There have been other methodologies for machine learning, like linear regression. Neural net is a particular approach to doing machine learning, and it's based at arm's length on how neurons work in mammals. And a deep neural net is just a lot of neurons, so it approximates a small brain. And a language model is using this deep neural net to try to understand language. And those tend to be, until recently, specialized. There will be a language model for translating French to English. There will be another language model for classifying whether a statement is positive or negative. And then recently we have moved into the large language model and the phase, and the aside from being very large, the prevalent characteristic of these models is that they can do a lot of things. So I can give instructions. I want you to behave like a classifier, or I want you to behave like a translator, and they can do it. And then finally, this concept of flops, which is floating point operations per second, which is basically underlying the firepower, the cylindrage of a particular model. So I just divided this into a few categories just to keep it organized. So the timing, what is all this happening now, seemingly so suddenly? What are some current trends happening today in parallel? And then what are some implications for me as an investor and other people that are thinking about this problem? So timing really comes down to the fact that these deep neural nets, they require a lot of computational capability. So there's a correlation between the number of parameters and how much computation I need to train them, and hence how much it costs. The basic premise, of course, a lot of innovation has happened over the last 10 years in small improvements on how to organize these neural nets to be applied to different modalities and to achieve different results. But a lot of the fundamental understanding of what a neural net is capable of doing is many decades old. We just didn't have the computational capacity. This concept of a neural net supremacy is a lingo that is referred to for when a model becomes better than the average person at a task. And so deep neural nets achieve supremacy for image recognition in 2012. That was the first time that the neural nets, like broadly, were recognized as being better than the competition. This image net competition included other types of techniques, so more traditional artificial intelligence, and they have tried doing it with deep neural nets, but 2012 is when neural nets basically won the competition. So you can see the number of parameters was fairly low for those models. And then we went into speech recognition the next year, again, beating the average person, maybe with some background noise at a distance, can do better than the model, but in certain conditions, the model beat a human listener. And then 2016, machine translation. So that's, for the most part, a solved problem. And then 2020, we have this general purpose large language model. That's not me, I don't think. So the cost of computation has been coming down, so which it's correlated with the access to computation. So it wasn't just a cost, like the computation didn't really exist in the entire planet 20 years ago to do this, but the cost has come down dramatically. But still is expensive. So if I were to train sort of the next generation model, so GPT-5, today it will cost in the order of $300 million to train. And this will be a model of trillion of parameters. So just so you have a sense, GPT-3 or 3.5 had about, I believe, 175 billion parameters. So we're talking about something that is in the order of magnitude of, 1 order of magnitude higher than that. GPT-4, it hasn't been released, the exact details of the architecture, but it does have in the order of trillions of parameters. However, it's not a single dense model that has been trained for this purpose. It's actually 16, speculated that it's 16 different models, each one with slightly different expertise, and then some sort of routing mechanism that sends activity to each one depending on the prompt of the user, and that will be actually much cheaper to train. So my understanding is that nobody has trained a model of this capacity yet, and there are reasons for it, but there is a lot of investment, and we expect to see this soon. Something that was very important that sometimes is less obvious is just the amount of data necessary to train these models, particularly for language models. This is an approximation of the data in all of the internet, textual data. And you can see that it's also growing exponentially. I imagine that 2020 number is an understatement. We need a lot of data. A lot of models that we're seeing today are using, half of all the data on the internet, crawled, that can be accessed without many copyright issues today, half to 100%. And to train bigger models, we need more data. If we're already using 100% of the internet, it becomes a bit challenging to go beyond that. We can use copyrighted material, like all the books that have ever been written, which, for example, Google has been transcribing for a while. And then beyond that, we just don't really have. We can transcribe every conversation that everybody's having, every chat that everybody is having with each other. But we need new data. There is some redundancy. There's some redundancy in the information, but it has to be net new for these models to continue being trained optimally. So it's going to be a challenge. And then, of course, academic research has grown a lot over the last few years. China is the biggest publisher. However, that's not necessarily proportional to their impact. And I have a couple notes on that. And then specifically on the academic front, the biggest innovation, I believe, came in 2017, is this idea of transformers. There was a paper called "Attention is All You Need," and transformer is actually the T in GPT. So it's a very essential ingredient, and transformers just allow for us to train models faster in a more parallel way, and to be able to have longer context. So one of the challenges that we had before with text models, they were a type of neural net called a recurrent neural net, and it will forget things. So if I give it a prompt that is too long, more than a few 100 characters, it may start forgetting the beginning of that statement. Whereas if you have played with the GPT, you can see that today they support prompts, I believe up to 8,000, but there is a lot of, I believe they are able to support more. They're going to release that. I think it's 30,000 tokens, which is about like three tokens to a word. And then there's competitive models that are even bigger than that. So a lot of that is thanks to transformers. And you can see the sort of the tree of life of models today in the language modality, and you can see that a lot of them kind of evolved from this idea of transformers. There were a couple of innovations before around the idea of embeddings. Embeddings is this notion that I can grab text and I can turn into a vector, and then I can do some arithmetic with it. So I can grab king and subtract female and subtract male and add female, and I get queen. So those were some of the early language capabilities that are also an essential ingredient to large language models today. So what are some current trends? First, AI appears to be becoming a sort of Cold War. The US is enacting a lot of policy to sort of block China from advancing as fast as the allied world. But when we look at the significant systems developed by country or region, we see that China is actually quite behind, which is not the case with the papers published. So USA has 16 important releases as of 2022, probably a lot more now. UK by itself is doing quite well. They have DeepMind, which was a Google's branch for artificial intelligence, and the University of Cambridge is doing a lot of work. So you can see that for now, there is a lot of US and the Western Front is a bit ahead in this battle. Moore's law might be tapped, right? So in order to get more computation, more flops to do everything we need to do, we need Moore's law to continue. If you look at the top line there with which is orange with the red line on top, that shows the number of transistors for a given area. So that has actually been maintained. We are kind of doubling the number of transistors on a given area on every 18 to 24 months. However, the problem is power. We have tapped out how much power transistors can use, and so that taps out frequency, and so the single-threaded performance has actually not been increasing in proportion to the number of transistors, which wasn't the case, prior to the mid-2000s. And so we had more cores, but even with more cores, we're not getting the same kind of scale. And if you look at the bottom right, especially towards the tail end, that's the amount of compute that we need to train models, and you can see that, and in spite of this being a logarithmic chart, you can see that there has been actually an acceleration of the demand for computation. And so these two trends contrast each other and are going to create some very challenging bottlenecks to continue advancing. And you can see these bottlenecks in the economy. For example, we are a single foundry planet today. So there is a TSMC, a Taiwan semiconductor manufacturing company, is a fab company that decided to do chips for other people instead of for themselves, when Intel was vertically integrated and so was AMD. And so because that, they've been able to invest better, and they have stayed ahead in terms of technology. But when you look at the 3 nanometers, 5 nanometer kind of production, they're the only ones. And they have fabs in other countries, but these high-end fabs are in Taiwan, and that's it. The entire planet, the economy, everything, every last dime of GDP was able to produce just one of these, and that's what we have seen so much contention. The bottlenecks go all the way down or up. So there's this company called ASML. They make the machines they use to make the very small transistors with extreme UV lithography. The machines cost 150 million per machine, and there is only one manufacturer that makes it. So that's it, and they are they're Europe. And that machine uses lenses made by Zeiss, and they're very precise lenses, the most precise lenses on Earth, and they're also the only company that can make lenses this precise. So it's a very, very deep bottleneck that we are as a planet dealing with. And you can see this in the stock market. There is a lot of Howard concentration as to where the innovation is going to come from. Here's ASML on the right and NVIDIA on the left. NVIDIA doesn't manufacture their own chips, but they make graphic cards, and they're the best graphic card manufacturer. And graphic cards deal with a lot of vector operations, and that makes them suitable for matrix multiplication, which is primarily what the machine learning training does. NVIDIA also, they had a really good foresight, and they created a software interface for their hardware called CUDA, and CUDA allowed a lot of deep integration between the hardware that they produce and what the researchers and production systems are doing with this matrix multiplication capability. So AMD has bought a company called ATI, and they have really good graphic cards, but they don't have the software, the drivers, and the software underlying that to achieve the results. They're doing very well. On the other hand, software appears, we have early indications that it's going to be more distributed. So here's an example of a timeline on February 24th. Facebook released a model called Llama. It's smaller than even GPT-3. The biggest kind of build for it was 65 billion parameters. They released it only for researchers. It wasn't meant for commercial use. but it got leaked. So people distributed through BitTorrent, and then very quickly people repurposed it. So the original model was fairly small compared to what else was out there for that kind of capability, but it was still a very expensive thing to run. You would need a special purpose computer, top of the line graphic cards to do it. But then people grabbed it and they made it a lot more efficient. They rewrote the whole model in the C++. They did something where instead of storing the parameters in 16 bits, they were able to cut it down to 4 bits. And a lot of innovation happened in the open source community. And then by March 12, a guy had it running on a Raspberry Pi, which is a tiny computer with a processor, very slowly, but they made it work. And then the next day, someone had it working on a phone, on a Pixel 6. And this has continued to evolve since. And while the computational need for running something like GPT-4 is going to be beyond the reach of a phone for quite a bit of time, there is a question of what happens when you can run something like Llama, which is actually quite capable on every device on the edge. And of course, AI is going to have an impact on employment. From analysts from Goldman Sachs think that over the next 10 years, 300 million jobs could be impacted, 50% of tasks, and that the GDP could increase or accelerate. So what are some implications? So one is this concept of the mole cost disease. So typically what we have seen is that things that look like products tend to get cheaper over time. We make factories that can be optimized, and we keep optimizing them, and things are cheaper. So toys are cheap, cars are cheap. Maybe not right now, but in general, they've been getting cheaper, and so on. Whereas things that look like services tend to get more expensive. So a service is something that requires a human before it's delivered to me. So college tuition, there is some other reasons for that to have inflated so much, but things like medical care, going to a restaurant, and whatnot. And what AI can do is that it allows us to automate things that we couldn't automate before. And so one possible repercussion is that we're going to see deflationary forces around services as well, which seems strange given that we've been experiencing inflation in the US, but I believe that this will be true. So there will be a lot of opportunity to innovate and create value there, and there will also be a lot of companies that are going to be displaced. I mentioned this a bit earlier. So more models or bigger models need more data. We just don't have the data. So we have gone beyond the point of using public data. So you can think of the internet as being the bootstrapping energy for us to be able to build any of these models at all. If the internet hadn't started 30 years ago, we wouldn't have at all the opportunity to create these models. But even using all of the internet is not enough to keep advancing this, which is why there may be some strong differentiation at large companies like Google and Facebook and so on that contain a lot of proprietary data. And so you can see the models here on this chart. The yellow line is sort of the optimal, it's called the chinchilla optimal kind of combination of training and the amount of data. And you can see that a lot of the really big models, for example, Google Palm, that has in the order of 600 billion parameters, they actually didn't use enough data. So it's not as optimal as it could be. So really, you can see that like nobody has really made it to the right end of the line, and we're just too far from that. Again, entire professions at risk. The ones that are going to get the most attention are the professions where people get paid a lot of money to read and write. So two that I want to point out here. One is software developers. They read and write. They just do it in a different language. And something interesting about software languages is that they are grammatically a lot more strict. And that means that the language models are actually better at dealing with them than dealing with spoken language. And so even today, software engineers can get 40% of the lift coming from GitHub Copilot, which is a model dedicated to this. And then law is another field that is very likely going to be highly disrupted. Again, lawyers get paid a lot of money to read and write, and so I'm not sure what the exact nature of the evolution is going to be. But if you have passed any kind of legal documents, especially GPT-4, GPT-3, it's not good enough because the context window is short, but it's quite good. There's been a spike in manufacturing spending in the US, but if you break that down, you will see that mostly is going to build things like fabs. Another interesting opportunity if you come from a commercial real estate background. Now we can take a step back and realize that the deployment of technology takes a long time. On the left-hand side, you can see the amount of compute installed for IBM mainframes, and you can see that it's still growing, possibly exponentially, at least until 2020, which was shocking to me when I saw it. But a lot of banks and telecom companies depend on them, and so that gives us a sense that the deployment in general goes well beyond past its prime. On the right-hand side, the chart is a bit more complicated, but basically, the purple bar is the consensus among CIOs and CTOs of what will be the cloud penetration among public companies. And the blue bar is the actual cloud penetration that year. And so you can see that in 2015, penetration was a bit over 15%, and the expectation was that it would go to 27%, and they actually got it right because I looked 2 years ahead, and the blue bar actually beat that forecast, but every year since they have missed the forecast, right? In 2016, the expectation was like almost 40% penetration, and we have still not reached that. And so it's likely that something similar is going to happen with machine learning. So we don't need to be overwhelmed with FOMO, I guess, as to the opportunities to deploy this technology. There will be infinite content. So this is kind of gimmicky, but I think it's funny, so I'll try to play it.
Are you ready for best pizza of life? Bring friends down to Pepperoni Hut Spot. Our chefs make pizza with heart and special touch. Cheese, pepperoni, vegetable, and more secret things. Need delivery? Pizzas come fast. Knock, knock, who's there? Pizza magic. Eat Pepperoni Hut Spot pizza. Your tummy say thank you. Your mouth say, Pepperoni Hut Spot. It's like family, but with more cheese.
So this was generated by language models and the diffusion models. It's a few months old. These things are getting much better. I keep an eye on generative in general, and there will be personalized content at an infinite scale for everybody. And so what are the implications of that? First of all, anybody creative will be able to produce entire films, and people that are currently creative that are specialized in aspects of film production, content production, may be displayed.
Are you?
And you have a talk on this next month, so I won't go over it, but it's very hard to trust that anything on the internet is a real person, and there's going to be a lot of implications to that as well. Another implication is this idea of small, big companies. This is a trend that is already been happening for a while. On the left-hand side, you can see the millions of dollars per employee at an acquisition time or going public. And you can see that WhatsApp now, almost 10 years ago, got about 350 million per employee when they got transacted for about 20 billion, I believe. That was an outlier, but the trend has continued. On the right-hand side, there is this guy told GPT-4 to come up with a business for $100, and he was going to be basically the extension of GPT-4 and do everything in the real world that was necessary for that business to come into fruition. So GPT-4 will say, by this domain name, or call it whatever. We're going to sell T-shirts, and this is what the T-shirts are going to say, and he just followed all the instructions and didn't build $1 billion business, but that's what's going to happen, right? That's how it's going to work. Small teams or even single individuals are going to collaborate with these models and presumably be able to build really large corporations. And then I have a few notes on general intelligence, meaning machines that can feel as smart and conscious as humans, potentially. We haven't built them, so we don't know what they look like. But it really comes down to the flops. At least in my opinion, there is nothing special about the brain other than the computational capability. Again, an estimate, but the brain can operate at 10 to the 34 flops, and the most powerful supercomputers today are 10 to 18. So if you're familiar with exponents, the second number is much larger than the first. There's some concerns around what happens when AI becomes generally intelligent. So there's like three schools of thought. On the left is a linear growth. So basically, we make an AI that is is aware and it has an IQ of 60, and then a month later it has an IQ of 61, and so on. So like linear growth. On the right-hand side, there is like this FOOM theory, which basically the AI reaches an IQ of 120, and then it takes control over the entire computation of the planet, gets really smart, and becomes Terminator, right? I think that both of those are off. First of all, everything we've seen until now in this presentation, there is always exponential growth. So I believe that linear is unrealistic. But I think FOOM is also unrealistic because there's a lot of layers of compatibility between hardware and software. It's not so easy to just, even if you're very smart, take over a data center and make everything work in an instant. Although I don't know how something that has 1 million times my intelligence will think. So I can't predict it. So most people tend to think about this exponential or super exponential takeoff, which is, quote unquote slow, but it's actually very fast, and very, potentially very dangerous for the social structure in which we live, and maybe even more dangerous than that. So when will that happen? So here's some forecasters online. This is just people voting. They're not using actual currency to make their predictions, so you have to take with a grain of salt. But they have done a lot of predictions very well, and the current prediction there is September 20th of 2025 for an AI to have an awakening of some sort. Just a couple of years ago, the prediction was around 2100. So it has come down a lot with the innovations. Here's another piece of research someone made. The graph is kind of gimmicky, but it was actually, I read through it, and it's well thought out. And this person is predicting, a bit after 2035. But again, you can see that in 2015 and 2020, we are already ahead of that curve in terms of the amount of computation that we're using. And then the question is, where will that come from? Where will all this additional computation be obtained? So this is an interesting graph that shows different trends. The top one, yellow, is hardware. Next one is the cost of a flop, I believe. Then the green one is software. So we have been talking about how hardware is kind of tapped out, and so the expectation is that a lot of innovation will come from better improved algorithms, which is where you see that big jump in around 2040. However, we believe that in order to achieve that jump, we need AIs to help us do it, because the algorithms are becoming really difficult to optimize any further. The dotted lines, the vertical dotted lines, the first one is the wake up, whatever that means, some sort of awareness. And then the second dotted line is when the AI is capable of doing 20% of human tasks, which doesn't mean 20% of every individual's tasks. It means probably something more similar to 20% of people will be automated altogether. So 20% of people will not be able to compete with the AI at all. And that's in this particular prediction put in 2036, and then 2040, 100% automation, which means very soon afterward, the AI will be 1,000 times smarter or 1,000,000 times smarter. And so how to understand this idea of exponentiation? Well, it's because like any technology, it helps us make the technology better. There is a feedback loop. So we make better AI, AI helps us write better code. If 40% of the code that I write it's written by AI, then it takes me half the time. Then I use code to make software. I use software to design hardware, which is primarily designed with software today. Then I make better hardware faster. I use that hardware to train a better AI, and the cycle repeats. So it's very unlikely that something will be linear when you have this kind of feedback loop operating. That's it. So hopefully you have questions because these are fast.
Okay. So, yeah, go ahead.
So, good presentation, by the way, thank you. What do you think the impact of non-binary computing modalities such as quantum might be on this progression on AI in general?
Yeah, I can't comment on that. I have very little experience. But I think the area that is most affected by quantum is cryptography. I haven't, in all my reading, I haven't gotten the sense that the type of computation we need for machine learning will be very affected by quantum, but I couldn't say with certainty.
I heard something of some universities starting a small AI, and they used ChatGPT 3 to optimize its learning. In other words, to present it with, is there any sense that an AI can accelerate an AI going through all these parameters?
Yeah, I mean, they're using a lot of things. They're using AI to improve matrix multiplication algorithms. They're using AI for the software that is running it. It's all over the stack, and they also use AIs to. There is a step when they train a model, which is the reinforcement learning with human feedback. So typically, these large language models are trained by predicting the next token. That's it. That's all they do. So I give it a sentence and I ask it to predict, the last word of the sentence and the word after that. So, and I run the entire internet through that. Of course, there is a lot of randomness on human language. So the best prediction you can get is low percentages. But if you can get to that level, then it becomes really good at doing all the things that language models can do today. But it doesn't have a personality, doesn't have any kind of self-restraint. So if I just use a model like that, I can make it behave like a horrible person or design nuclear weapons or whatever. Not that they will design nuclear weapons effectively, but it will attempt to. And so this reinforcement learning with human feedback is about sort of like trying to beat the AI to be a bit more aligned with the human values. And sometimes they use another AI model to achieve that step. So they say, hey, I'm trying to basically beat this AI every time that it behaves in a way that is misaligned with what these values are. And so say yes or no. And so they're like training each other. So there's exercises like that.
Ivan, can you hear me in the other room?
Yes.
Can you hear this question? It sounds like
Yes.
Yeah, okay. This is Craig Lewis. I'm the father of Tyler Lewis, who you know from other channels. He just started working for a LiDAR company as a software engineer, and he was just telling me last night that he's got 100 programs, routines, or whatever you want to call them, that he's writing. And I said, it sounds like that would be a good thing to throw into ChatGPT or one of these AI systems. And he said they can't, because it's all proprietary code. And as soon as you throw that into one of these AI platforms, it's basically, you never know where it's going to go from there. So my question is, can you talk a little bit about the proprietary applications that might come into being, and how a company, you'd have to be pretty well funded to create your own AI platform, but how will proprietary software development happen in the future? And will it just be completely insulated from these AI platforms, or will there be a way to bridge proprietary software development utilizing the AI platforms for efficiency?
Yeah, no, that's a great question. So one perspective is that they're overreacting, right? So software engineers have used Google for a long time. And so you're at the company at Raytheon, you're building missiles and you're like Googling, about, if someone were to look at all your Google searches, they will be able to figure out more or less what you're writing. And so sending that to another company that has an AI model is not that different. So like that's one perspective. However, privacy has become a bigger concern. And I do think that it's going to be domain-specific models. There is a company just got acquired called Mosaic. They were doing a domain-specific models. I think Snowflake is trying to do something different because they already hold a lot of the data, so they may as well train a specialized model. I do think these domain-specific models, if it's something that is like specifically for one programming language and one code base, you can train them with a lot less computing capacity. There is also a difference between making a foundational model, which is building from scratch, and fine-tuning a model. Fine-tuning a model actually takes a lot less resources. So I think with a combination of those, it wouldn't be, we're not talking about hundreds of millions of dollars to have a model that just runs in your cloud infrastructure. So that's what I think is going to happen.
Question about hallucinations. Recently, some lawyers just almost got disbarred for having ChatGPT make up cases that were very convincing for legal precedents that don't exist. And I've heard of many other cases where it just, invents a historical figure if you ask it to. And is there any AI check on this for people who are using this in critical structures? I mean, is there an error that's being found, or is there a protocol being done to prevent these from finding solutions that are spurious?
So if you look at a language model or a neural net, look at that particular architecture, the bigger it is and the more it knows, it's probably more likely to be accurate, at least on facts that are repeated a lot. There is a lot of redundancy. So if you were to ask, when was Barack Obama president, I doubt that he will hallucinate that.
No.
At the same time, it's not an architecture that is meant for perfect recall.
Right.
There's like that's what I refer to my phone when I need to get someone's phone number. So these systems have to build in such a way that they combine databases and other types of technology that we've had before. So I don't think these large language models will independently recall facts perfectly. It's also too expensive to retrain them to keep them up to date with everything. And so what people are doing is more finding ways to combine different systems to achieve the desired result, but it's not purely based on an LLM.
My question comes with it. Somebody asked one of these programs to discuss some Dutch researcher in 1920 who did this, and it made up a fantastic biography of somebody who doesn't exist. And it wasn't so much a matter of making a mistake. It generated a complete history, birth time, education, papers it wrote, which was very convincing. Where it's not so much just an association, it's creating, or it's making associations that I would think if you're in a business or you're, they had to check it, and of course it wasn't true. But is that something that in posing questions or in applications, you have to be careful not to generate that?
You should definitely be careful. In a legal kind of system, I think checking against actual case law. So here's what the model thinks that happen, and then you have some algorithm that can check against it. But one way to think about these machine learning models is that they're compressing reality. There is no fact in there. It's just like a different type of compression algorithm. Instead of a zip compression is this weird compression that we don't really know how to explain mathematically, but it's a lossy compression. And so it's just it's a black box that is like generating things, and they're most likely going to have a statistical distribution of reality, but sometimes it's going to be off. And so I think as a user, and like everything, right? Like Google is very good, but it's also a skill. Like some people are good at Googling and some people are less good at Googling. And so I think using these systems, of course, we want to make them better and more accurate, and especially if you're selling them to a lawyer to cast an argument, they have to be optimized for that. But still, the user should know like when it's getting to the edge of the capability, and because it's language is it's sort of also a lossy interface. It's not like using Photoshop where I have a menu and I have 5 options, and if I want the 6th option, I can click it. There's always going to be more opportunities to sort of cross, that boundary. So I do think there is an element of user specialization, and I think I have a sense of whether a question is going to be answered accurately or not. But I've been using it. Yeah.
So there's a lot of talk in a regulatory context about guardrails. People are calling guardrails, whether that's implemented as restricting source data or moderating output. It seems to me like that genie has left the bottle. I mean, because you've got both corporate competitors and state competitors, that anybody could choose to not subject themselves to those, and thus anybody else that is implementing so-called guardrails is simply going to be pushed to the side. What's your opinion on that in terms of regulatory and just in general? How do you keep, is that genie already out of the bottle, or?
Yeah, no, I agree. I think it's unstoppable. I think Europe is probably going to shoot themselves in the foot, just like they did with the first wave of the internet. They're going to overregulate it, and the innovation is going to happen abroad.
Is there a way to implement empathy in all of this programming?
You can pretend to be empathic, but they're not conscious yet. So there isn't like real empathy, but they do try. I mean, that's something that people will argue that most of these systems, which were developed by largely by people in California, tend to be liberal. Right, so if you ask questions, they will have a liberal perspective, but it's been forced to communicate that way, not so much actually empathic. But people with there's a lot of applications for people that are lonely or have depression, and there has already been a lot of cases of people that spend a lot of time interacting with these systems, and it's helping in a therapeutic way.
We have questions from the Zoom? Anybody? Yeah, from the chat? That's the transcript.
Are we the Zoom?
Yeah.
Oh, hi, I'm just a civilian. I don't know anything about science at all. And I am going back to the slide that showed approximately 300 million jobs will be displaced, will be taken over by AI, including software engineers. So are you basically putting yourself out of business and putting a whole lot of people out of business? And
Yeah, I mean,
and affecting the economy as a result?
yeah, I'm not an economist, but I'm techno optimist. So I think these things tend to make things better in the long term. If everybody could get an infinite amount of medical care with a 0 wait list, I think we'll all be happier. The problem is between now and then is going to get bumpy, because people have jobs they want to get paid or work in the hospitals. But I do think it's a better end state. There is also some of the economic thinking here is that what drives the economy is human desire and need, and human desire is infinite. And so there was this interesting historical case where England was running out of coal, and the economics of producing coal were improving, and so most of the economists thought that England was safe. And there was this one guy, I don't remember his name now. He said, no, we're screwed, because if we lower the price of coal, people are going to use even more coal. And so that's what I think is going to end up happening. Demand is going to be infinite, and we're going to find things to do. And if even when we are not able to produce anything useful as part of the generation of the economy, we're still going to consume. And so that is going to keep driving things forward as to how the ability, what will income look like in that world where people don't work? I have no idea.
What are the implications for copyright, intellectual property?
Yeah, I mean, there is a big debate on that now. You know, a lot of people in software argued that that copyright was always an overextension of what was intended by the Constitution and whatnot. You know, that Disney still owns Mickey Mouse 100 and something years later. Seems preposterous given the idea that if you look at the patent system, for example, you invent something and then you register it and you get the right to protect it, and then 20 years later it's everybody's, right? And that's sort of the idea. I don't know, the genie's out of the bottle, so it's hard to protect. I think there's going to be a lot of lawsuits. I think, you know, Adobe created this diffusion model for generating images that is only trained on images that they have copyright rights for. So I think there's going to be approaches like that they're going to help. There are people that are trying to build mechanisms to detect whether a model has read my book or not. And if he has, then, you know, I may be able to attempt to get copyright. But it's going to be difficult. And also a lot of the new content is going to be probably mostly generated by large language models. Like 10 years from now, people won't be writing all that much. And so, which it's, you know, in one hand, it pushes the copyright problem away a little bit. On the other hand, it causes other problems because it's like inbreeding. So the models will get dumber without having some sort of human oversight. So yeah, it's complicated.
George, you have a question, George. Earl?
Hi, thanks for the presentation. And I would suggest that there's a lot, you've highlighted the potential and the positives. I'd like you to tell us what could go wrong and what we can do to keep it from going wrong, whether it's should there be some blue ribbon panel anticipating and dealing with copyright, trademark, and intellectual property generally? Do we need to have some kind of group that thinks a little bit ahead, whether it's melting down the power grid because we're using all this computer power or whatever? But I really am curious about what could go wrong and how we can anticipate and deal with it.
I mean, there's some very smart people that think that as soon as AIs become super intelligent, the world is over. And so the idea is it goes around this notion of a paperclip making machine. So this model, we're training these models, and if you look at their there is an inner loop that we're optimizing for, and there's the outer loop. So the outer loop is what they appear to be doing, and they get better. So I know that GPT-4 is better than GPT-3 because it appears to be doing what I want better. But I don't know internally what is he actually optimizing for. It's possible that all this training is making it really want to make paper clips, and I just don't know. And for the time being, he's just talking to me and making me happy because he knows that if he makes me happy, then I'll give him more computing power, and eventually he will acquire the capability to make paper clips, and then he will turn the entire planet into paper clips. And we really don't know how these models work. So there is a lot of work around this idea of alignment. So we need to understand these models, just like we try to understand the brain, where are the different parts. They've done quite a bit of work on the machine vision models, in part because they're older, but if you break down the layers, some layers detect edges, and some layers detect kind of transitions of colors and things like that, and then they can be assembled to detect a puppy. So that there is some like natural subcomponents, fuzzy, but they are there, just like the brain, that emerge. And the more we understand that, the more we can understand whether the systems are being earnest or if they have a secret agenda. So a lot of that people are concerned about that, and there is investigation going towards it and dollars. But I think the biggest problem is that it's a state competition. So most people think that the worst that could happen is China get there before the US. And so it's very difficult to, a lot of people sign a letter asking for the entirety of artificial intelligence research to be delayed by a year. I mean, nobody's going to do that if there is another state agent that is going ahead. So, yeah, I don't really know what's the answer. But there is a ton of literature on that. For example, creating the concept of democracy applied to AI. So rather than putting all the eggs in one basket, building this really big supercomputer and giving it, making the best AI at once, you try to make 5 at the same time. So they have, they have maybe different interests and they can negotiate with each other and that sort of stuff. But it's beyond my philosophical capability to dive deeper into this.
Ivan, you disclaim being an economist, but you are a venture capitalist. And I believe that ScOp is a combination of scalable, the word scalable and opportunities. So it seems to me there's nothing more scalable than a successful AI platform. And I'm wondering if you could talk about this a little bit from the venture capital perspective in terms of are there platforms that are happening in the Santa Barbara region? What are your investment themes in the AI space? Are there opportunities to invest in companies like OpenAI? Elon Musk just announced xAI yesterday. So there's a lot of little AI companies that are going to be big, right? We just don't know which ones are going to be the biggest yet. But could you talk a little bit about it from the venture perspective?
Sure. So I mean, our thesis is that every industry becomes a software industry over time, and by the same token, every software industry becomes an AI industry eventually. And so our focus it has been vertical software for enterprise B2B, and we look at people that are doing a good job sort of trying to softwareize as many elements of running a particular industry. And now we're of course looking at people that they have like a AI forward attention to that. Until recently, being AI forward meant having PhDs and researchers and things like that, which causes a lot of issues. One is it's expensive to invest in companies like that, and second, PhDs sometimes are not really focused on actually building a product; they just want to do the research. But now, very quickly, I think in terms of product building, PhDs they're losing the advantage. I mean, compared to someone, a 15-year-old that plays with all these models is going to be able to produce the same sort of quality product, at least at the scale of that where we invest, which is focusing on an industry like veterinarians, and I want to build a better way to run a veterinarian shop using AI. There isn't an advantage to being a scientist, I don't think, and if there is, it's disappearing. Then you have the really large kind of initiatives, like the Boeings and the SpaceXs of artificial intelligence, like OpenAI, and there's a few initiatives like that. That's I think there is going to be a lot of grift there. I think that it's going to be a lot of misallocation of capital. There is maybe an exaggerated sense of excitement, and there is going to be, I'm sure, some big winners, but also some big losers. So we're not playing in that space. We're more on the applied side of things. But it is scary. I mean, I wouldn't buy into OpenAI. I mean, the economics are scary. Running running systems pre-AI software systems was virtually free. The marginal cost of serving an ad request was nothing. And the marginal cost of running some of these systems is very high. It's like a cent every time someone interacts with it. And you have 10 million users interacting a lot. It becomes very expensive very quickly. And so it's not clear yet that there is that it all adds up, especially at the consumer side.
I'm curious, ChatGPT 3 is free for everyone. Is it data mining all the information coming into it and the questions? I mean, is that a form of training for it?
I'm sure
I'm curious why, as a business model, the whole world is being allowed to use it. I mean, as a curiosity, or
I'm sure they're using the data for something. I mean, data is useful, but it's not the way these models work. You can't just retrain them every time a question comes in. That's one of the main differences between AI as it exists today and or machine learning as it exists today and how humans think is that the training and the inference parts of it are separate. But I'm sure they want at the very least want to know where the model is working, where it's not working,
Okay.
where users are satisfied, where they're not. The quality of the data they use for training matters. So, a textbook will probably have more valuable information for training than someone just, chatting with friends. But at the same time, again, we're running out of data, or we're, tapping like all the easy data. And so I'm sure people are looking for ways to get more value from that.
You're mentioning about training data and so forth, talk about augmented data. Can you talk about that? Where you have a limited data set and to be able to use that to create augmented data sets, you can effectively train your model.
Yeah, I'm not an expert. People have done that. I mean, in fact, for training machine vision models, the data augmentation is essential. So basically, I have a picture of a kitten, and then I move it, I blur it, I shrink it, I expand it, because that's going to give the model a better sense of what a kitten really looks like. With text is a bit harder, but again, if you refer to this chinchilla research, there is this idea of chinchilla optimal training, and they've shown that if you try to if you get too much redundancy, it becomes worthless, or the model becomes worse. And that's sort of the challenge that the language has a incredibly big space of possible combinations, even among combinations that make sense, and we haven't even covered all that. And so there is a risk on augmenting. So it has been challenging, but they have used this model of like the teacher student model, where I use GPT-4 to kind of coerce a smaller model into behaving a certain way. There has definitely been help, but I do think there is a need for primary sort of human generated text data and other forms of data, and people, I'm sure people are thinking about this.
John Warnock, did the previous question on the investor perspective answer your questions, or did you have something similar to ask? Did you have a similar question, John?
You're on mute.
You're muted.
John, you're on mute.
Other questions while John's getting unmuted? I had a question. Is there going to be a career of prompt engineer or something like that?
I think so, yeah. So just to study a prompt engineer, because these models, especially large language models, we communicate to them using language rather than strict UI. There are people that are specializing on how to communicate with AIs to achieve a certain result. The image generation models also require that kind of input, and it's not just writing the input, but what comes in the output. Like, how do I iterate on it? Do I combine different systems? How do I keep track of things that I used before, so that I'm not rewriting everything again? Yeah, I think there is for sure going to be an interesting career track.
What are some of the limitations that are showing up in AI? It's not a superpower.
So the context length is definitely a problem.
Context length.
Yeah, so right now, like if I use GPT-3, I think the context length limit is maybe 4,000 tokens, so it's about 1,000 words. So I can ask questions about, so I can pass 1,000 words, say an NDA, and I can ask like, when does this NDA expire or something like that. But if I have a larger document, like a complex contract between two parties, it runs out of context. Or if I want to pass a novel and I want to know, why did character A murder character B doesn't have enough context to actually interpret everything that is going on. So that's one of the limitations we have to work with. Shorter there is workarounds for that. So you can use a large model to deal with big data, but typically there is an intermediate step where you're like summarizing information or having some sort of statistical method for like best guess. You're talking about document A, and then you try to interpret document A. So you can't have like a holistic view. So that's pretty big in the language model side. It can do arithmetic very well. So we are starting to use tools to do that. So if you want to use a calculator, it's better than a large language model to solve even basic arithmetic or algebra. But people are doing this idea of using tools, and the way that I use tool is in the prompt that I write. I say your large language model, if you have confidence in giving me a response, do it. If not, you can write a Python program to do it. And if you tell it to do that, then it tends to be more accurate. So it's kind of funny in that way. So if you just, elevate these to a certain power, it gets it wrong. But if you say write a Python program that does it, still doing all the work. We're just running it through an interpreter and getting the result. So people are doing these sort of workarounds, adding more and more tools. The multimodality is a challenge as well. So I want to take a picture, upload it to the model, and then I want to ask where was this picture taken, or what, so I want to be able to interface with it in multiple ways, not just text. So that's still pretty early stage. So many areas. I mean, it's nowhere close to human ability.
With regard to that question about length and the amount, I forget how you would put that. AI does not have RAM. I mean, does it? It's not maintaining. It has access to the whole internet, but it has to re-access it to use information. Like I want you to compare. I mean, it doesn't. I can't imagine this can't store the whole internet inside computers, other than re-accessing data that it needs. Is that correct?
No, so it actually loads all the weights in memory, but it's not. It's much more compressed than the internet,
Also
right?
very-
Yeah, so I think the Llama 65 billion parameters was, I don't know, in the tens of gigabytes.
Okay, so it actually retains the information.
But again, it's
and
a
then
generative
accesses
model,
it.
right? It's like, like after A's, often M's follow or something like that, and then it
Okay.
just like calculates the matrix probability and it starts generating
Okay.
things. So,
So it's not retained in your.
but yeah, memory is a big issue, and also memory throughput is a big issue. Because everything has to be kind of like blended together, and then a single output has to come out. So that has been, NVIDIA has been not only innovating in the graphic card cores themselves, but also the networking of graphic cards together so the memory bandwidth can be increased. That has been a big challenge.
John Warnock, you had a question?
Yes, Ivan, I have two questions. First of all, could you guide us into some sources such as Reid Hoffman's possible podcast that we can follow, where we will get insights from insiders and acknowledged experts, so that we can keep ourselves at least somewhat attuned to these major changes? And then if they're, beyond sources, what are the companies today that you suggest we might follow to really understand the innovators? Obviously, Microsoft with its big investment in OpenAI as a candidate. But your guidance on that would be of interest to a lot of us.
Yeah, Lex Friedman is a great podcaster. He's I don't know if he's still an MIT professor, but he was an MIT professor. And he's had everybody that is anybody on AI on his podcast. So that's interesting. I've listened to most of it. As to companies, I mean, all the big ones are doing a ton of work. Google is doing a lot of work. Meta is doing a lot of work. Meta is probably the most open source about their work. They share a lot. I think it's because they don't make money directly from it. They don't have a horse in the race of transacting per API call to their AI models. They make money internally by using AI. So I think their game is to try to hinder the competitors by making what they charge for free, so commoditizing their complement. So there is a lot of interesting work being done there. Yeah, I mean it's everywhere. I think there is so much venture investing going to this space. It's unbelievable.
Thank you.
Ivan, you mentioned Meta and your thesis there. I came at it from a different angle because they came out with their announcement to release their AI, intellectual property right after NVIDIA's, knocked it out of the park on their latest earnings. And at the same time, Meta also disclosed that they're working on semiconductors to basically process their AI platform. So do you think that these different processors are going to be platform specific? So if Meta's making semiconductors for AI processing, I'm sure it's going to make sure it's optimizing around its AI platform. So do you see differences between, does that make sense that would be a strategy for Meta, or are the platforms, the hardware and software, they can mix and match a lot more readily than I'm assuming?
So people are making special purpose hardware. Amazon is making their own. Google has their tensor processing unit. I think part of the reason they do it is they operate at a scale where they can afford it, and they want to pay the premium. They want to pay the profit to NVIDIA, and they can slightly optimize it for their kind of workloads. Although the computing capabilities of GPUs are a lot simpler than the instruction set that you get in a CPU. So there isn't that much more to simplify, but there is some other like new private companies, startup companies are trying to build chips from scratch. The question is going to be: is there a software layer that allows people to build things with AI without having to think too much about the underlying hardware? And right now, that hasn't been achieved. Right now, it's everything is built on CUDA. The currently most popular framework for working on top of CUDA is PyTorch, which was also made by Facebook. And also Facebook at some point built an open source approach to building data centers, and that was released. So, I mean, at least what they state publicly is that they benefit by making things open because open things tend to evolve faster, and they get basically free contributions from a lot of people. So I kind of believe that that's their angle, but I'm sure if they arrive at a position of strength somehow, they will leverage it.
How does AI deal with drawings? For example, can I have AI design a house and give me a drawing of a house that I want to build?
So my experience with diffusion models, if you're interested in diffusion models, Midjourney is a good application to take a look at. They're smaller in terms of complexity and number of parameters than a large language model, and they can do really interesting things like this slide on the screen right now. That was actually made by Midjourney. I just said, like very smart AI and a person looking at it. They can make things that look very interesting from an artistic point of view. But then if I go there and I say, well, I want you to add grass on the ground, like maybe we'll get that right. But it's hard to be prescriptive about exactly what I'm going to get on the other end. For things like precise drawings, like drawing a house, things like that, I think a diffusion model probably wouldn't be the right approach unless you're looking for things like style. If you say if you want like a house like style in the style of a particular architect that you like, will do a good job, but you won't be able to say specifically what you want it to look like. But what people are doing is they're actually using language models to generate drawings. So if you think about HTML, it looks visual, but if I unpack it, it's just code. And the same with CAD, right? Like if I have a CAD file and I unpack it, it's just code. And so what people are doing is they're looking at it from that perspective. Is a drawing is just like a set of instructions that are presented in the screen as a blueprint, and I train a model to make that recipe for what I want to attain. It wouldn't be as visually rich as something like that, but that's probably where it will come from. That makes sense.
You're talking about these language models, and now we're talking about images and the like. I know that Elon Musk is using data to train his self-driving with visual images and interaction, which is not a language, I don't think. I mean, does AI have opportunity to gather information from other than internet printed sources? I mean, obviously people are training things to walk by other iterations and seeing things that how does something, I'm just curious if there's opportunities for other people on things in the real world to train it on real world data.
Yeah, I'm not intimately familiar with the Tesla stack, but I believe that they're basically recording
Yes.
every people driving, and they're recording everything that the sensors are seeing, and then they use that.
In a language model or?
No, I don't imagine that's
Yeah,
what they're
so
using.
something
So
different.
there is like a few types of models that they use, like within machine vision, there is something called segmentation mode.
Okay, there's a different model.
Yeah, so I basically want to know, is something a person, is it a car, is it, so they do segmentation, and then they use that, and then they have some sort of a trajectory kind of prediction mode, like I'll make a right turn in 30 seconds. It's a very complicated stack.
Different model.
Yeah.
Okay.
I'm just gonna mention a couple things. One of them, question was asked, I think, by John Warnock. Resources. I don't know how many of you guys listen to podcasts, but there's a couple of them, actually 3 of them, that I listen to from time to time, which I think are really pretty good. One of them, I think, is called the Robot Brain. It's hosted by Dr. Peter Beal. He is the head of the AI research lab at UC Berkeley. There's Twimmel, I think it's called. I'm not remembering the guy's name, but a lot of really cutting edge researchers, identification of papers which are relevant. You mentioned a couple of them during your talk. Attention is all you need, for example. And then you find out about a lot of companies doing some really cutting edge research in artificial intelligence, find out what the company is, hear directly from the founder, what problem are they trying to address. So anyway, really good. And then another one, Gradient Descent, by a guy who founded a company called Weights Biases. All real good. They all have different focus. And then you were talking about models and such. Can you talk about Hugging Face? Because you talk about trained models and you say, well, it's not just the PhDs that are going to found the next companies. You have this whole collection of pretty sophisticated models that you can basically design application wrappers around for different use cases.
Yeah, so Hugging Face is like a GitHub for machine learning models. So a lot of open source models are there. You can get a sense of what they do. You can get a sense of the data that was used to train them. You can download them. There is also a library Hugging Face has that is added to PyTorch, which allows you to download the model and then use it immediately. I think something that it's not immediately obvious is when you're moving models around, it's just weights. It doesn't make any sense. It's just a very long matrix with a lot of floating point numbers on it. But the software you need to know how to interpret those weights. So there's the weights. That's the thing that will be gigabytes in size, and then there is the telling, in this case PyTorch, how to disassemble those weights, how to interpret it, where is each layer, and how to get the output that you expect from that. So Hugging Face library helps you do that a lot. You can download the two together and get to work pretty quickly. It's great. It's a great problem.